So we have an IP question here. 6a, show that log base 9 cos 2x plus 2 is equal to log base 3 root cos 2x plus 2. So we can start with the left hand side and we can use change of base formula to write log base 9 cos 2x plus 2 with a base of 3. So this is just log base 3 cos 2x plus 2 divided by log base 3 of 9. So we know that log base 3 of 9 is just 2 because 3 squared is 9. So this is written as log base 3 cos 2 divided by 2, which is just 1 by 2 into log base 3 cos 2x plus 2. So we also know that any number into a logarithm is just the logarithm raised to the power of that number. So now we have log base 9 cos 2x plus 2 is equal to log base 3 cos 2x plus 2, 2x plus 2 to the power 1 by 2. And that anything to the power 1 by 2 is just the root. So we have log base 9 cos 2x plus 2 is equal to log base 3 root cos 2x plus 2. And that is what we were asked to prove. Another thing to note is that this question is 3 marks. So it shouldn't take you any more than 1 minute or 1 minute 30 seconds or maximum 2 minutes. So part B, answer otherwise solve log base 3 2 sin x is equal to log base 9 cos 2x plus 2 for 0 less than x less than pi by 2. Okay, so when you have answer otherwise, you can really do this question however you want to, but it's always easier to look at the note the hence part and use the answer from part A to solve part B. So we can just rewrite this first. Log base 3 2 sin x is equal to log base 9 cos 2x plus 2 is what we're trying to solve for the domain. So we just found another way to write log base 9 cos 2x plus 2, which is log base 3 root cos 2x plus 2. So we can input that here. Since we have the same basis on both sides of the logarithms, we can just remove the logarithms because the part that's inside has to be equal. So 2 sin x is equal to root cos 2x plus 2. Squaring both sides, we get 4 sin square x is equal to cos 2x plus 2. Now we have sine square on one side and cos on the other side. So we want to have a singular identity, either sine or cos. So in the data booklet, there's a formula that says cos 2x is equal to 1 minus 2 sine square x. There are other ways of writing this, such as 2 cos square x minus 1 or cos square x minus sine square x. But since we have sine square x on the left hand side, we want sine x or sine square x on the right hand side. So replacing cos 2x with 1 minus 2 sine square x, we get 4 sine square x is equal to 1 minus 2 sine square x plus 2. Grouping alike terms, 6 sine square x is equal to 3, or sine square x is equal to 1 by 2. And sine x is equal to plus or minus. Do not forget the plus or minus, because whenever you take square root, it's always plus or minus. Plus or minus root 1 by 2. Simplifying, it's plus or minus root 2 by 2. So the first solution, sine x is equal to plus root 2 by 2. X is equal to sine inverse root 2 by 2, which you should remember is always pi by 4. There are technically other solutions, but for the specified domain of 0 less than x less than pi by 2, it is only pi by 4. So the second part is sin x is equal to negative root 2 by 2. The smallest positive solution for this is 5 pi by 4, but that does not fall within our domain of the restricted domain. So there are actually no more solutions, and the only solution is x is equal to pi by 4. Um, One thing to note is that when there's more than one solution in a question, they'll usually specify, uh, give the list the solutions or solve or give the solutions of this, solutions being plural. But you should always verify that there are if there are more solutions or not.